Today, we have a Bankless Take talking about David's recent article, The Unified Architecture for Ethereum. Where does Ethereum fit in the world of many chains? We got Bitcoin over there, we got Solana, we got Celestia, we've got other layer 2s. What is Ethereum's future there? Also, what functional escape velocity means and why it's important. And finally, David's conclusion. Eventually, everything becomes a branch on Ethereum's tree. That's what he says in the article. It's safe to say today's episode, I think, David, it's going to be a bullish Ethereum episode, but I would say, at least from the tone and tenor of the article, it also acknowledges the design choices of other chains and the spaces that they have carved out and will continue to occupy. I don't know. Would you say this is an ETH Maxi episode, David?
I think you can see many things in this article. I think somebody else could rewrite this article from a perspective of their particular chain. And so it's one part like, hey, here's how I've come to the conclusion that I've come to about Ethereum. But the parts of this article are universal. So we can always place chains in relations to other chains on a particular axis. And then I've also proposed an axis for like kind of understanding where chains kind of fit in relation to others. I'll talk about like why I wrote this article and what listeners I think can get out of it in a second. But first, a message from our friends and sponsors over at Safe. This is a message for all the devs out there. Safe is, of course, formerly known as Gnosis Safe, securing billions and billions of dollars in the world of Ethereum and on its layer 2s. It's also leading the transition to the world of smart accounts, making embedding wallets super easy to integrate into your daily crypto activities. And Safe wants you to build with Safe smart accounts. They also want you to go to the SafeCon happening during the Berlin Blockchain Week, which is going on at the 3rd week of May. If either of these two things interest you, click the links in the show notes to get started building with Safe today.
All right. So when is that Berlin conference? The 3rd week of May, you say?
3rd week of May, yeah.
All right. We're back in conference season, it sounds like.
Yeah.
All right. Why'd you write this article, David?
Yeah. So I've had this article like in my brain for like almost 2 years now. And it is kind of carrying forward a very early conversation, probably the earliest big conversation in the crypto space that I think really ever emerged, which is the Bitcoin block size wars. Bitcoin block size wars were just concluding as I was getting into crypto, and some of the fallout was starting to happen. This is right when Bitcoin Cash started to become a thing. It's right when the Bitcoin camp divided into two based off of philosophical differences. And I think that a lot of people coming into crypto in modern times don't really have this lesson of like the Bitcoin block size wars and what it means for crypto. It's kind of something that this weird thing in history, but I think it's actually much more emblematic of a lot of the tribes that we've seen today. Like Bitcoin split into two tribes based off of philosophical differences. Now in crypto, we have like a plethora of tribes. We probably have too many tribes. Each one of these tribes believes some philosophical truth about the design construction of chains. And so I kind of attempt to define the landscape of tribes based off of what was one of the original like cellular divisions of the Bitcoin camp. One going to the small block camp, one going to the big block camp. And then I also kind of explain the grand unified theory of design architecture for blockchains is like an allusion to that whole like grand unified theory of everything in physics, but for design architecture. I explain like why Ethereum occupies this particular spot in this trade-offs landscape that tries to maximize for everything and incorporates everything, which is why you get the tagline, eventually everything becomes a branch on Ethereum's tree. So that was motivation here.
Well, let's get to it. But before we do, we want to thank the sponsors that made this episode possible, including our recommended exchange for 2024. That is, of course, KRAKEN. Go check it out.
If you want a crypto trading experience backed by world-class security and award-winning support teams, then head over to KRAKEN, one of the longest-standing and most secure crypto platforms in the world. KRAKEN is on a journey to build a more accessible, inclusive, and fair financial system, making it simple and secure for everyone, everywhere, to trade crypto. KRAKEN's intuitive trading tools are designed to grow with you, empowering you to make your first or your 100th trade in just a few clicks. And there's an award-winning client support team available 24/7 to help you along the way, along with a whole range of educational guides, articles, and videos. With products and features like KRAKEN Pro and KRAKEN NFT Marketplace and a seamless app to bring it all together, it's really the perfect place to get your complete crypto experience. So check out the simple, secure, and powerful way for everyone to trade crypto, whether you're a complete beginner or a seasoned pro. Go to kraken.com/bankless risks to see what crypto can be. Not investment advice. Crypto trading involves risk of loss. Have you heard about Safe? They're not just pioneers in crypto custody, they're also leading the transition to the world of smart accounts. With Safe, managing your crypto has never been smarter or safer. They've recently passed $100 billion in total value secured and are now deployed everywhere, with over 15 supported networks. But that's not all. Safe is revolutionizing the game with their full compatibility with ERC-4337, making embedding wallets super easy to integrate into your daily crypto activities. So, what are you waiting for? Head over to safe.global to join over 8 million others in securing your crypto. And while you're there, don't forget to check out SafeCon, happening during the Berlin Blockchain Week, where the future of smart accounts is unfolding in real life. Secure your spot today and be a part of the transition to smart accounts. Click the link in the show notes to learn more and take your first steps towards smarter crypto management. Taking self-custody of your crypto is one of the most important things you can do on your bankless journey. It's also one of the hardest things to get right, with huge consequences if you don't. If you want help going bankless, talk to Casa. Casa helps you take custody of your crypto assets so you don't have to wonder whether you're doing it right. Casa is a one-stop shop for doing self-custody the right way. With Casa Vaults, you can hold Ether, Bitcoin, stablecoins, all with one simple app and multiple keys for the ultimate peace of mind, with a support team to help you every step of the way. But it doesn't stop at self-custody, because even though crypto is forever, you are not. We all plan on making life-changing wealth in crypto, but with Casa's inheritance product, life-changing wealth can elevate to generational wealth for your kids and your loved ones who don't know anything about crypto. With Casa, you won't lose your private keys and you won't accidentally take them to the grave either. Click the link in the description to get started securing your generational wealth.
All right, David, let's start here. We got to go back all the way to 2015 through 2017 when something called the Bitcoin block size wars was going on. These were formative days for me in crypto, as for you. But this was a debate that was really like occupying all of the mind space, all of the mind share of crypto, I would say for like a good 12 to 18 months at least. Take us back there and tell us what that was. Give us the context.
Yeah, interestingly, I think the first ever podcast I ever listened to in the crypto space was Laura Shin moderating a debate between a big blocker and a small blocker. And I was like, somebody tell me how a blockchain works. And
you didn't understand any of it?
I did not understand a damn thing that was going on. That was like my first introduction. Let
me ask you, when you first heard that on like unadulterated, like virgin ears, whose side were you on? Were you like,
I was too early for any of that. I was trying to understand anything. Like the words were not going into the brain. It did not compute.
Do you know whose side I was probably default on or more receptive to?
I'm gonna guess.
Go.
You were a big blocker.
Yeah. It just sounded like I was like, big blocks. Yeah, like why have small blocks when you can have big blocks? It's just like this was Bitcoin Cash. You had sort of the argument for big blocks, and that's what that tribe and that fork sort of became. But it was just they're like, we can do so much more with block space. If only we had more block space.
Yeah.
And so it seemed
just make
like
more block space.
Yeah,
so
it seemed like there was a tribe of like old grandpa Bitcoin people, curmudgeons that were just like shaking their canes and saying, "No, we want small blocks." That was my default, like no knowledge sort of. I'm just hearing for the first time. Quick judgment. I quickly refined my views after learning a bit more about it, but that was my immediate reaction.
I think that was my introduction to the space as well. Arguing with my first podcast co-host, who was a big Bitcoiner, and I came into the space and just like immediately identified with Ethereum. My arguments to him were like very big blocker arguments. And so like maybe we can go into and define like big blockers and small blockers, because like a lot of people's arguments about how you should build crypto or what crypto should look like can be characterized as like a big blocker or a small blocker argument. And so big blockers in the Bitcoin space advocated for this basically was a debate of like, how do we scale Bitcoin? Bitcoin is this thing now in 2015. In the future, we want it to support the entire globe.
And you know why? Because gas fees on Bitcoin were getting really expensive. Like transaction fees were getting expensive at this time, and people were angry about it.
Yeah. So famously, there was always this like one sat per byte, or like the lowest possible fee for Bitcoin blocks, basically free. And then in 2015, 2016, they started to creep up. And then all of a sudden people were like, oh, like, how are we going to scale Bitcoin? How are we going to take the world and put it on top of Bitcoin? How do we scale the network? And so two philosophical debates forked in the Bitcoin culture to become the big blockers and the small blockers. So the big blockers advocated for just increasing the raw size of Bitcoin blocks from 1 megabyte to 8 megabytes, allowing for like theoretically 8 times more transactions, which would lower transaction costs. Small blockers advocated for keeping the block size the same and argued that increasing the block size would compromise Bitcoin's decentralization, because if you make blocks bigger, you make blocks harder to verify, which is a core principle of blockchains, is that the blockchain should be trivial to verify for users. Users need to be as sovereign as anyone else in the system. And when you increase the scope of the complexity of the layer one, then you actually make it more difficult for the long tail of humanity, the long tail people, to partake in the validation of the Bitcoin system.
Well, let's define what that means when you say users, right? Because users cast a very wide net. You could be a Bitcoin user by just holding Bitcoin. You could even be a Bitcoin user in a way by holding Bitcoin on the exchange, right? That's not like the deepest use case, but like just holding Bitcoin, yourself, self-custody keys. That makes you a Bitcoin user. I would certainly argue that. What you're talking about is a more advanced type of user who is not only holding Bitcoin, but also running a Bitcoin node to validate the transactions from the miners. All the proof of work miners, they put out blocks. This gives somebody who chooses to run the Bitcoin software the ability to validate that those transactions are in effect, correct. So it is a user, but it's a slightly more advanced user because it's a user that's actually running Bitcoin software.
Yeah, I would contend with one nuance of that, which is that you say like slightly more advanced user. And a big blocker philosophy would actually make that like a much more advanced user, where a small block philosophy would be like, well, no, actually, that same user that's holding BTC on Binance or Coinbase, they could become the same user that's verifying the actual layer one, because it's not that hard to do.
Because the node requirements are light. You can
The
run a
node requirements are light,
Bitcoin
and
node on
therefore
a
the
consumer
hardware requirements are light. So
Right.
your shitty PC from 1992 can actually become a Bitcoin node.
Oh, wow. You think so? 1992?
I don't know. I just made that up. But the point is like, if you desire to, if you are merely a Bitcoin holder, but you also desire to become a validator of the network, which is different than Ethereum. Validator is just processing the Bitcoin transactions self-sovereignly and verifying them.
Verifying
That's
them, yeah.
not a complex thing to do, and you could become that person because it's trivial to do.
Yeah, you're democratizing that, right?
Yeah.
Whereas the big block path, where it eventually leads, is no one can run a node unless you have like state of the art
Right.
compute, and
Right.
maybe the end of that is like you're in a data center somewhere,
Right.
and so no normal person is able to actually validate the blocks. That's where big blockers kind of end up if they
Right.
continue to 8x block size.
Right. And so the small blockers would also point to the big blocker argument, saying like, if you just raise the block size of Bitcoin from 1 to 8 and allow for 8 times more capacity, that's like still not anywhere close to enough. Like, we eventually need infinity transactions in order to scale this to the globe. And so small blockers advocated for a different scaling strategy. They call this alternative path SegWit, for segregated witness, which is basically a mechanism for just removing signatures from transactions and then bundling them together. It was a block optimization strategy. So rather than increasing the size of blocks, you would keep the blocks the same, but be able to do more with the blocks. So more transaction density inside of the same size of blocks. And this would also open up scaling solutions outside of the Bitcoin core protocol called layer twos. This opened up like Lightning Network. This is what made Lightning Network more feasible, more possible. And now many other like
Ordinals.
ordinals, like ordinals, like a
Runes.
lot of Bitcoin expressivity comes out of this SegWit thing. So just like really the 2 points of emphasis here: small blockers wanted to scale Bitcoin in 2 ways: increasing block density by making individual transactions more valuable, more compact, more economic, more efficient, and then also scaling up layer twos, creating room for functional off-chain scaling solutions. And so they just pointed out, if you just increase the raw size of Bitcoin blocks, it's just like increasing lanes on a highway. You're just actually going to induce demand, and you're actually not going to actually solve any of the problems of scaling. And in fact, you're actually going to make Bitcoin less decentralized. Fast forward to the end of the Bitcoin block size wars, Bitcoin Cash forked out of Bitcoin in 2017. And we all know the price action of Bitcoin Cash. Actually, it's like still in the top 25, which is kind of crazy.
It
I
did
think
really well at first.
it did really well at first, and then it's been down only
There
ever
was
since.
talk of like Bitcoin Cash flipping Bitcoin and
Right,
like who is right.
right,
And like eventually it kind of failed off. And like, what is Bitcoin today? No one
right.
talks about Bitcoin Cash.
Yeah. But that was like a lesson in history, right? And so this whole small blocker, big blocker debate, I think, like rings through the halls of crypto history and still persists to this day. Like all layer ones exist somewhere on a continuum between small blocker and big blocker philosophy. And we don't really often like define it as small blocker or big blocker philosophy. We use other terms. But this ideologies, these two different ideologies do come to like
They
resonate
persist.
more strongly with some tribes other than others.
Well, let me just, this wasn't in your article, so it's a brief side quest, but I think
Mhm.
is important is in terms of how that decision was effectively made. Like, what is the canonical Bitcoin?
Mm.
Because an alternative Bitcoin fork called Bitcoin Cash actually had a lot of legitimacy in the early
Yeah.
days,
Had a lot
and
of
some of
community,
that
yeah. Mhm,
legitimacy was coming from the community, of course.
mhm,
Some miners preferred that as well. Many exchanges were on board with that, and in fact, like I think Coinbase, and
mhm.
at one point in time was sort of more on board with the Bitcoin Cash. Like Brian Armstrong came out supportive ish of Bitcoin Cash. As I recall at the time, at least the small blockers charged him with
Right,
being overly supportive with that.
right,
But how was the decision actually made? Because this as well is kind of like a victory, let's say, for a decentralization or some sort of
right,
check on power. What wasn't it, David, the case that the nodes themselves
right.
sort of like voted and decided the outcome of what the true Bitcoin was? Can you describe that a little bit?
Yeah, even a large supply of the Bitcoin miners were more in favor of Bitcoin Cash because if they did the calculus, they did the napkin math, and they determined that they could actually make more fees with bigger blocks. And so a lot of the hash power of Bitcoin miners went over to Bitcoin Cash in support of Bitcoin Cash too. So like there was a large number of just like institutions and players in the space that were like, oh yeah, I'm be happy with a big block outcome here. But ultimately, it came down to people running nodes, people running the Bitcoin node software, and more individuals running the Bitcoin node software elected to stay on the Bitcoin, the small block, the original instantiation of Bitcoin. Now, notably, I think possibly we could have ended up in a world with Bitcoin as like 8 megabyte blocks under a different set of starting conditions. I think if Bitcoin started with 8 megabyte blocks and then small blockers came in and said, hey, we should fork Bitcoin into becoming 1 megabyte blocks, I think the small blockers would have lost. My opinion is actually that like it's because of Bitcoin doesn't want to be changed. And so Bitcoin started off as 1 megabyte blocks and the big blockers wanted to change Bitcoin to be larger. I think whichever side was going to win was the way that Bitcoin already was from Genesis. That's kind of like in my rationale.
So let's talk about modern day. So this is somewhat ancient history in crypto. David, it's almost like 10 years ago that
Yeah.
this happened. Okay. So like why does
Most
any
crypto
of
people
this?
did not experience this.
No, and they don't care. And like
Yeah.
whatever. It's Bitcoin. I mean, we're talking about other networks now. It's nothing
Mhm.
to do with Ethereum, is it? Or nothing to do with Solana. So what does this look like in modern day?
I think the easiest example to extrapolate into is the Solana versus Ethereum camp. Solana is the big blockers. Ethereum are there. We're the small blockers. There's also other axes that have also emerged. So now this is not just like the only axis for viewing a chain, but this is like one of the original continuums that was a point of contention between tribes, between debates. And so like we'll talk about some other axes that also kind of help define what a blockchain is, but like big block for small block is like the original trade-off design space that facilitated a bunch of debate in crypto. I mean, like we see some of these same arguments, right? Like the Solana camp says that Ethereum is too expensive and too slow to get the world on chain. Consumers aren't going to use crypto until transactions are instant and free, and we need to engineer as much capacity as possible into the layer one. Sound familiar?
Yeah, increase the size of the blocks,
Right.
increase TPS, transactions per
Yep.
second, fit more stuff like
Mhm.
inside of the blocks that this layer one produces.
Right. The Ethereum camp says that this is a fundamental compromise on decentralization and credible neutrality, creating an enshrined set of winners and losers, and ultimately produces the same set of socio financial stratifications that we're trying to get away from the world of TradFi. So instead, we should focus on increasing the density and value of layer one blocks, fees at the layer one, and force scaling up to the layer twos. So the whole point is like this debate is nothing new. We have different like playing fields, different landscape to have this debate, But like debates are always the same. The debates have never really changed.
Yeah, it's interesting because Solana is, of course, not a fork of Ethereum, so it's a little bit
Right.
different in that way, but it's a similar philosophy, right? And
Mhm.
so, what compromises exactly on decentralization and credible neutrality do you think that Ethereum would say a big block chain
Mhm.
like Solana is actually making here?
Yeah, I think this debate is even easier to see in Ethereum versus Solana than Bitcoin versus Bitcoin Cash, because even though Bitcoin Cash was 8 times larger than Bitcoin in this grand scheme of things, compared to like the monolithic layer ones that we have today, Bitcoin Cash is like a small block blockchain. Because the size and capacity and sophistication of Solana blocks and the Solana virtual machine has like it's literally trying to optimize for the furthest end of the spectrum. And so like let's
And it's
just
better engineered, right? Because it's not
it's
just a straight
totally better.
Bitcoin
Yes.
fork, which was
Yes.
just like not meant for
Right.
parallelization and like high TPS anyway.
Bitcoin Cash was just absolutely not optimized from an engineering standpoint to do anything that Solana is doing. So
Right.
Solana is like, hey, let's engineer this from first principles, which sets Solana off at like a much better position than like Bitcoin Cash ever would have, right? So like, hey, let's build a brand new virtual machine that's hyper optimized for scale, right? Let's build this piece of engineering that's hyper optimized to run on this very particular set of hardware, these very strong bits of hardware. And so like that to Solana's benefit, like it has been able to like construct a big blocker design philosophy from first principles where Bitcoin Cash never had that opportunity. And that's why Solana is what it is. It is like big blocker philosophy taken to its logical conclusion.
But how does this manifest into the charge that it's like,
Mm,
why not do that? You know,
right,
like Ethereum
right.
says it's not decentralized enough. And one
Hmm.
bit of difference between the Bitcoin big blockers and small blockers is with Ethereum, with the move to proof of stake, anybody with a certain amount of ETH can be a validator in the network,
Yeah.
not just verifying the transactions and running a node, a non-validating node, but also producing blocks. They can be a
Hmm.
block producer with Bitcoin, that's kind of blocked right now. You can't be a
Right. You
miner.
can't
You
be a
can't
miner.
produce blocks unless you have data center and access to super cheap
You can't
energy.
produce blocks unless you have economies of scale in the
Okay,
Bitcoin
so
system.
does it come down essentially to Ethereum by constraining its block size is basically making it such that anybody with consumer hardware has
Hmm.
the ability to run a node that produces blocks to be a validator, essentially. Is that what it comes down to when you talk about decentralization?
Yeah, Ethereum, you can with consumer hardware can both produce blocks and independently in a self-sovereign way check the validity of other people's blocks. So you aren't trusting any intermediary to tell you which block is correct or what transactions are correct. You are doing it yourself. And Solana, like you could do it yourself, but it's so much harder. The hardware and sophistication is just a much higher threshold to get over. And this is the trade off that the Solana ecosystem has made. It's like we're like users aren't going to do it anyways, so we're just going to go ahead and like trim that feature of like user self sovereign verification from the blockchain because they're just not going to do it. So we're going to juice this thing, and we're actually going to fit more people on chain. We're going to have lower transaction costs and higher fees.
I mean, this is a point of detail here because some people contend with that, right? Which is
Hmm.
like, no, David, you can run a Solana non-validating node from your home.
Hmm.
Like you totally can do that. It costs more. It's
Right.
not you can't run it necessarily on your just like your standard MacBook Pro, like cheap
Right.
edition.
Hmm.
But spend $3,000 or something or $5,000, get a more beefy machine,
Yeah.
and you can run it. Of course, you have to increase your bandwidth maybe, but you could still sort of run a non-validating Solana node from home. So like, what's the big deal?
Yeah, I guess it's just a debate as to like how far away from end consumer verification we are willing to get. And like I think it's actually bandwidth that's the biggest bottleneck to like it's just stronger Solana decentralization. And bandwidth is just like, all right, what's the topology of the world, and how good is the bandwidth across
You
like
need some fiber,
you need
something
fiber. Yeah,
higher
yeah, you
bandwidth,
get
that kind
one
of
gigabit.
thing.
Yeah, I think like the actual hardware is so you need good hardware and you need to be proximate to bandwidth. And so we've started to meaningfully like constrain the possible validating set of humanity to Solana.
I think
And
it's just important to note though, this is a
mhm,
sliding scale, right?
right, it's a
So
sliding scale.
like you still can't run a Bitcoin node on like like hardware that's 15 years old. I would
Right.
expect, or maybe you
Yeah.
can, but
Yeah,
like
you might be able to do that
you
actually.
can't run an Ethereum node. non-validating node on a 15-year-old computer, right? And then Solana moves it like farther in terms of to the right to actually like in terms of resource consumption to run a non-validating node. But it's all spectrum.
Yeah. I think maybe to define it, like with Ethereum, Ethereum wants to make it sufficiently easy to verify the Ethereum blockchain so that like you don't have to try to verify the Ethereum blockchain. The background processes of your typical consumer hardware can verify the Ethereum blockchain. So you don't have to actually really try. With Solana, like you have to actually be meaningfully motivated to verify the Solana blockchain. And like maybe it's not that hard, but like the point is like you actually have to like produce like coherent effort to actually make that a thing. And so that's kind of like defining the gap between these two chains. And so this is just modern day big blocker, small blocker stuff, right? I want to also introduce a second axis into this, which is related but also meaningfully different, which is the inclusion of a virtual machine. Bitcoin does not have a virtual machine inside of Bitcoin Core. It has individual opcodes that can do computation, but like the computation is constrained into like whatever that opcode does. And so there's no virtual machine there. Celestia also does not have a virtual machine inside of its blockchain. And so Celestia just accepts arbitrary data. It just accepts blobs and puts blobs into Celestia blob space. And that's what Celestia does. And so now we have like this two trade-off axes. We have what I'm calling block sophistication or block complexity, which is having or not having a virtual machine. And then you also have small blocks versus large blocks, whereas Bitcoin occupies the corner of a very non-complex block state, as in like verifying internally to Bitcoin. It's not that complex. There's not that many opcodes. There's a finite number of opcodes. And it's also got small blocks. Celestia, massive blocks, 1 gigabyte size
Real
blocks.
big.
You can put a gigabyte of data inside of a Celestia block. It's massive. It's crazy. But it's actually they're so simple. They're just rudimentary, primitive, by design, intentionally simple blocks. They're dumb blocks. And what that does is pushes sophistication upstairs, up to the layer 2s. And so so Bitcoin and like Celestia are small blocks and large blocks of simple blocks. But then you have Ethereum, which is small blocks of complex blocks because it has a virtual machine. And then Solana is like much more complex and much larger. And so like it has truly optimized for like and this is why Celestia occupies like this most complex type of layer 1 blockchain, which is why we call this a monolithic blockchain.
Some other analogies for block space, the complexity of the block space is expressivity. Like how much can you fit and express, or programmability of a particular block. A couple of analogies that people have used in the past is if Bitcoin is kind of like a ledger or just an Excel spreadsheet. Well, Ethereum is like an Excel spreadsheet where every individual cell is like a program, is like a macro that you can you can run, right? Or if like a non-VM unsophisticated blockchain is, to me, sometimes I look at what's possible on Bitcoin. I'm like, wow, it's amazing what you can do on top of like a TI-83 calculator. Like I used to have like friends who would just like play Doom on their TI-83 calculators. It's like versus a computer, right? Where you can have much more sophisticated types of like technologies. But even there, the difference is like small block and big block, expressivity versus on like non-programmable block space.
Yeah. And I really just want to dive into this like last point, block complexity. So block complexity, which is like, do you have a virtual machine? Do you not have a virtual machine? How many opcodes do you have? Like this was the Ethereum like introduction to the space, is like it was the first blockchain with a virtual machine in it. All blockchains before Ethereum were just like, hey, we'll add features by adding more individual opcodes, like a finite serial number of opcodes. And like, oh, we just discovered this new feature. Let's make an opcode out of it. And Vitalik was like, this is silly. We're just going to make opcodes into infinity. Let's just make a virtual machine and put a virtual machine.
Do you remember the term Turing complete? It became very popular there, which is kind of like a nerdy term just to say that you could do anything you can program inside of the block.
Right. Yeah. And so this, to Bitcoin philosophy, adding a virtual machine inside of Ethereum was just like, how dare you? Like, deep sin, don't do that. It's adding complexity to the blockchain, which reduces people's ability to verify the chain. So this is why Bitcoiners, like honestly to this day, don't like virtual machines in their blockchains
It'll get
because they,
hacked. Like
yeah,
there's problems with it, right?
risk
And
risk surface area, like all this kind of stuff. And so it actually is a reduction of the user ability to verify the validity of transactions themselves. And if you remember going back into like 2017, 2018, like the Ethereum community was relentlessly bullied by the Bitcoin community because you could never run an Ethereum node. Like the state bloat was going to get too large. Like you
in the
could never catch
future,
up
they
to the
said,
chain.
like, you
Yeah.
could run it now, but your change just started. In the future, this is gonna just expand out of control, and
Yeah.
you run a node. There's
Right.
also, like, a lot of, schadenfreude after the DAO hack when they said,
Mm-hmm.
"Ha! See what happens when you make your blocks programmable?
Right. Uh-huh.
Somebody can hack a key contract and take a large portion of the supply," right? And what do you have to do? You have to, like, fork, or
Mm-hmm.
a fracture will enter new community. So I think many Bitcoiners felt very vindicated in
Yeah.
that era.
Yeah. Interestingly, like to this day, basically every single new layer one blockchain is a smart contract for virtual machine blockchain. Ever since Ethereum, everyone's like, okay, we do smart contracts now, except for Celestia,
Except Celestia, yeah.
except
That's
Celestia.
interesting.
Yeah, it is super interesting. Mantle, formerly known as BitDAO, is the first DAO-led Web3 ecosystem, all built on top of Mantle's first core product, the Mantle Network, a brand new high-performance Ethereum Layer 2 built using the OP stack, but uses EigenLayer's data availability solution instead of the expensive Ethereum Layer 1. Not only does this reduce Mantle Network's gas fees by 80%, but it also reduces gas fee volatility, providing a more stable foundation for Mantle's applications. The Mantle Treasury is one of the biggest DAO-owned treasuries, which is seeding an ecosystem of projects from all around the Web3 space for Mantle. Mantle already has sub-communities from around Web3 onboarded, like Game7 for Web3 gaming, and Bybit for TVL and liquidity and on-ramps. So if you want to build on the Mantle network, Mantle is offering a grants program that provides milestone-based funding to promising projects that help expand, secure, and decentralize Mantle. If you want to get started working with the first DAO-led Layer 2 ecosystem, check out Mantle at mantle.xyz and follow them on Twitter at 0xmantle. Launching a token? Don't let complex legal and tax issues slow you down. TOKU provides specialized support to optimize your launch and ensure that you as a founder and your team and your investors get the most tax-efficient outcomes. The TOKU team understands the crypto space inside and out and will ensure your token launch is fully compliant while maximizing tax efficiency. TOKU can connect you with the best attorneys if you need them to make sure that you have the best advice, and TOKU can help to optimize your taxes so you pay the least possible amount of taxes while still maintaining legal compliance. With TOKU's guidance, you can concentrate on building your company while TOKU handles the logistics. Token launches don't have to be complicated. Talk to TOKU today to get a free initial token valuation. CELO is the mobile-first EVM-compatible carbon-negative blockchain built for the real world, driving real-world use cases like mobile payments and mobile DeFi. And with Opera MiniPay as one of the fastest-growing Web3 wallets, CELO is seeing a meteoric rise with over 300 million transactions and 1.5 million monthly active addresses. And now, CELO is looking to come home to Ethereum as a layer 2. Optimism, Polygon, Matter Labs, and ARBITRUM have all thrown their hats in the ring for the CELO Layer 2 to build upon their stacks. Why the competition? The CELO Layer 2 will bring huge advantages like a decentralized sequencer, off-chain data availability secured by Ethereum validators, and one-block finality. What does that all mean for you? With CELO Layer 2, gas fees will stay low, and you can even pay for gas natively using ERC20 tokens, sending crypto to phone numbers across wallets using Social Connect. But CELO is a community-governed protocol. This means that CELO needs you to weigh in and make your voice heard. Join the conversation in the CELO forums. Follow CELO on Twitter and visit celo.org to shape the future of Ethereum. Okay, I want to get into this Vitalik article this is where we go next, called Base Layers and Functionality Escape Velocity. And this is where I start to put in some more opinions into this article that are from me. My personal crypto investment thesis, and I think you agree with me, Ryan, is that the blockchain that incorporates both big block and small block philosophy in its design will ultimately win. This is why I think Ethereum is going to eventually flip in Bitcoin. I think both.
Wow, you still believe that? Oh,
of
this
course, I
is a
still believe
maxi
that.
show. Okay.
Both big blockers and small blockers are correct. It's not about who's right and who's wrong. They both have valid points. The point is to build a system that maximizes both of them. And so Bitcoin, as an architecture, was not able to fit both big blockers and small blockers into its system. The Bitcoin small blockers said scaling is going to happen on layer 2s. All the big blockers should just go build on Lightning Network. But Lightning Network was a dud. It literally could not house. It was not a tent for big blockers. Big blockers couldn't achieve their goals there. And if you understand anything about psychology, if when you cannot access your goals, if you cannot achieve your goals, you go elsewhere. You do something else. Like if you're blocked, you go around it. And so a lot of ultimately what became Bitcoin big blockers, a lot of them became Ethereum people when Ethereum was around. So Ethereum like absorbed some of the Bitcoin big blockers. And so the constraints of the Bitcoin layer one could not house big blockers. And so that's why the thing forked. And so a couple quotes I want to read from Vitalik's article here. He basically argues for minimally increasing the functionality of a layer one in order to produce highly functional layer twos. So 2 quotes. While a layer one cannot be too powerful, as greater power implies greater complexity and hence greater brittleness, a layer one must also be powerful enough for the layer two protocols on top that people want to build to actually be possible in the first place. Keeping the layer one simple and making up for it on layer two is not a universal answer to blockchain scalability and functionality problems because it fails to take into account that layer one blockchains themselves must have a sufficient level of scalability and functionality for this building on top to actually be possible. So this is actually Vitalik saying, hey, from the Bitcoiner perspective, we need to have more big block philosophy in the layer one, but not too much more. And so like this is how I would summarize this article. We need to increase the scope of layer one blocks beyond small block maximalism in order to ensure that layer twos can achieve functionality escape velocity, which is like we need block sophistication. And then we should also not increase the scope of layer one blocks beyond the point of achieving layer two functionality because this unnecessarily compromises on layer one decentralization and credible neutrality. Any additional utility on the layer one should instead be pushed to the layer two. And so we need block sophistication, we need block complexity, because that is increasing the functionality of the layer one to the benefit of the layer twos. And then after that, we should maintain a small block philosophy. And this, to me, represents a compromise between both parties.
Well, isn't he just re-articulating what you just said, which is like small blocks that are expressive? Yeah, like this top right quadrant. He's just re-expressing that. And this post was written in 2019, and I would say encapsulates the Ethereum design philosophy in general.
Right.
There are other people who disagree with him, entire tribes that disagree with him. Bitcoin says, yeah, we like the small blocks, whatever, that's cool, but we don't like the expressivity, right? And then Solana says, we want big blocks and expressivity.
And more expressivity.
And we can do it. We can do it too. And why are you artificially constraining your blocks in the first place? So to me, that's just Vitalik explaining Ethereum philosophy. I guess that's your point, though.
Yep, that's exactly right. Well, and it's also why Ethereum became Ethereum. And so, like, if you agree with this philosophy, you end up in the top right quadrant here, which is like the Ethereum quadrant. And so, like, this ultimately gets into like what has emerged as the way that a lot of the core devs view the Ethereum layer one, which is as what they call a root of trust, which is also like a technical engineering term. A root of trust is a source that can always be trusted within a cryptographic system. That's the definition of a root of trust. Sounds like the Ethereum layer one. So like the Ethereum layer one maintains its small block philosophy by leveraging advances in cryptography to produce functionality escape velocity at higher levels. And then it accepts fraud proofs and validity proofs from layer twos onto the layer one. And then it can compress an effectively infinite number of transactions from its layer twos into this very easily to verify bundle, because that's what a ZK proof is, that's what a fraud proof is. And then those proofs are then verified by a decentralized network of consumer hardware. So whereas like we typically have been talking about this like big block, small block trade-off continuum, kind of like as a horizontal landscape, like Bitcoin on one side, Solana on the other. In my mind, Ethereum actually flips this continuum vertical and it says, hey, put the small blocks on the bottom, call that the layer one, and then put all the big blockers, all the big block chains on the layer twos. Remember when Jesse was like, hey, with Base, the Base blockchain, Jesse from Base, we are going to target 1 giga gas a second, which is a 400x increase in Base transaction capacity. That's a huge big blocker philosophy. And it is putting all of its assets and its proofs onto the Ethereum layer one. And so to me, this is actually where a lot of these synergies blossom because we have big blocks on top and a small blockchain that is the anchor to this whole big block universe up top.
Right. So I guess one implication of that, and this was a term I think we learned back in like 2019, I would say, is economic density of the blocks on the layer one themselves. Right. So if you have small blocks but they collapse the transactions of an entire chain's worth or entire
Mhm.
chain ecosystem's worth of economic activity. Well, you have incredibly economically dense blocks, right?
Mhm.
So these are like neutron star level
Mhm.
like density types of blocks, and that's been both Ethereum's philosophy, but it allows and Bitcoin's, but Ethereum allows for enough expressivity to make layer twos actually like possible and like easy. Although I would say now Bitcoin is
Mhm.
starting to like, hack in ways to store data inside of its opcodes and
Mhm.
create layer twos as well. So it's sort of like a tree is springing up, maybe like a twig, like the root of a tree. An early stage seedling is springing out of the Bitcoin layer one too. It's not as mature and robust as Ethereum's tree, but like that's starting to happen as well. Do you have any takes on that?
Yeah, it's actually been really interesting to see Bitcoin discover data availability. This is what happened when Ordinals was birthed on Bitcoin. Ordinals basically created this idea of Bitcoin as a data availability layer, and you could just inscribe JPEGs to it, and we could have fun with that. Babylon is a Bitcoin restaking platform that wants to build the Cosmos vision on top of Bitcoin, which also is what Celestia is doing on top of its layer one. And so, like,
BitVM as well, which is,
yep.
makes actually like some kind of a like a poor man's optimistic roll up
Mhm.
happen on Bitcoin, which is kind of neat.
And so Bitcoin, Ethereum, and Celestia are all like leveraging their own layer ones as a data availability layer to build more or less the same ecosystem on top of them, which I think is like super interesting that like we have three different types of layer ones, and they all want to build more or less what is the Cosmos vision on top of each respective layer one.
But doesn't all of this point to kind of the convergence aspect of all
Hmm.
of this, which is
Right.
like Bitcoin's going to converge on Ethereum strategy? And also, if you go to the far big blocker like side of the equation, there's no reason Solana can't have hypothetically layer twos that settle down to Solana.
I'm not sure about that actually. Uh,
Why? Why don't
well,
you think that's possible?
Well, because the whole big blocker philosophy is like if you need a second layer, you've effed up on your first layer. Like
Yeah.
this is actually like what I think what Anatoly and Mert like almost exclude, like that is their narrative. It's just like a second layer is emblematic of failures of the first layer. And so Solana of these three quadrants, Solana is the one that doesn't want layer twos. It's going to have layer twos for sovereignty purposes, but not for technical purposes, is like the Solana maximalist
Do you think
approach.
that's true? Like, I just because there's certain Anatoly or Mert kind of like want that. Do you truly don't see a layer two network kind of like emerging on top of on top of Solana because there's no technical reason why it's not possible, and if Solana
That's not
truly
true.
is like
No, so no,
permissionless,
no, no. Okay, so like the whole idea of like it's difficult for users at the layer one to verify the blockchain. A user can be another blockchain. And so if Solana, if you make it a difficult to verify blockchain, layer twos also have that difficulty of keeping up with the Solana chain and actually being a part of the Solana system. You can build a layer two on Solana. It's just immensely more difficult than it is to build on a much more slow, decentralized,
wait,
easy to
why?
verify
Why is
layer
it
one.
more difficult? Just
Well,
because
because it's
like
the technical capacity of the layer two has to also keep up and verify the state of the Solana layer one.
the speed at which
Right.
the hmm.
And so if you have an optimistic rollup on Solana, like you could, it's probably going to be easier to do a ZK, but you've had an optimistic rollup on Solana, like you need to be doing computation and you need to be doing a lot of computation, both on the layer two and the layer one in order to even produce the fraud proof.
I wouldn't mind like vetting that. I bet that there's some sort of like Solana's answer to layer two, but let's take that aside. I think you're
Mhm.
right from a narrative perspective. Definitely the Solana big blocker motif is like why have layer twos? Layer
Right.
twos are dumb. Like the monolithic chain is like another way or integrated chain as
Mhm.
like maybe a different way of putting the same thing. One quick side quest on this, David, is I think in the interim for Ethereum, one thing to note that it is moving in terms of its use case. Like, so I think Ethereum layer one used to be for people and individual users. So the
Mhm.
time we got into crypto, 2017 when we started using it like a lot in the early DeFi, you did everything on layer one, right? Like users used
Yep.
now because Ethereum is moving to this high economically dense root of trust type of configuration. Ethereum really isn't meant for average everyday people anymore.
Right.
Like it's unaffordable. You have to be a
Mhm.
whale. You have
Yep.
to be an exchange. You have to be some sort of batch of
A fund.
transactions.
Yeah.
You have to be a fund. You have to be a chain. You have to be something. And the users can go use layer twos and layer threes, but it's still going to be expensive to use
Right.
Ethereum. One thing that leads people to is the conclusion that Ethereum is too expensive.
Mhm.
I'll put that in quotes. But I actually think that's a really bad take because it kind of depends who you are. If you're looking at it from a chain's perspective, if you're the base chain, here's some
Mhm.
stats for you. The base chain has already made $40 million in terms of revenue. A few days ago, in one single day, it made almost $700,000 in revenue. And how much did it pay Ethereum for that? 2,500, where the root of trust cost $2,500 to settle to Ethereum. So an entire chain is making like, 700K a day, and its costs are 2,500 to Ethereum, right? From the chain's perspective, from Base's perspective, that's really, really cheap. And from users' perspective on Base, so long as their transaction fees also are low, they will be cheap for them as well. Anyway, what it leads to, I guess, is my point is there's this awkward transition phase that Ethereum is in right now, where it's like moving from a settlement layer for people to a settlement layer for chains. And
Mhm.
it's causing a lot of like this cycle, a lot of narrative like pain for it
Mhm.
because it almost like feels like a pivot, I think, to the
Right.
community. Do you have any thoughts on this?
Yeah, I actually want to put a pin in that because I think we're going to get to that exact point. But I want to start there with talking about the Cosmos vision. So we're talking about like Celestia, Bitcoin, Solana, Ethereum. What about Cosmos? Why aren't we talking about Cosmos? Um, Cosmos, the way that Cosmos people explain it is actually not a technology. There's no Cosmos chain. There's no any one particular thing that is Cosmos. Cosmos, this is the way that Sam Hart articulates it, is actually a choice. It's an idea. Cosmos is the choice to build a sovereign application that seeks to interoperate with others. And so the more sovereign your layer two is, the more that you've embodied the choice to become a Cosmos app. And so there's a lot of like resonance with the Ethereum layer two landscape and the Cosmos vision. Because again, just to articulate, the Cosmos vision for the world is many, many, many sovereign chains that desire to interoperate with other sovereign chains. And so, as you were saying, like Base is a sovereign chain, except for one small nuance that we'll get to. But it's highly economically secure because of the benefits of being an Ethereum layer two. And you can also interoperate with other chains via the Ethereum layer one. And so, go for it.
Yeah, I would say it feels really sovereign. Like
Mm-hmm.
if like for Base, they have the ability to deploy their chain. They can take
Mm-hmm.
all the revenue, whatever. They just have to pay some sort of defense fee to
Right.
Ethereum, and it's
Which is
not
the
that
which is
expensive
the
right now.
main point that Base is actually not perfectly sovereign. And so in the same way that there's a trade-off landscape between functionality escape velocity that Vitalik defined, I think there's also a sovereignty escape velocity kind of phenomenon where like layer twos do make some sacrifices to their sovereignty to a common shared settlement layer that we call the Ethereum layer one. So all of them, that at least is the model for rollups. Not all of them are doing this, but they all will do this. Will create fraud proofs and validity proofs. These are cryptographic proofs, and they will commit to posting them to their bridge contract on the Ethereum layer one or onto like the blob space. And so there is this some internal operation that they commit to some external like landing zone, the Ethereum layer one. And so that is the trade-off that layer twos have made that make them not perfectly sovereign. Some other chain has control over their fork choice rule. Some other chain is where they post their fraud proofs. But by making that trade-off, they become highly interoperable via cryptographic assurances. And so there's like this image that I pulled from Harry Potter. I don't know if you're a Harry Potter fan, but like the unbreakable vow. Like you
Yeah.
can make an unbreakable vow in Harry Potter, and then if one person breaks the vow, then they die. So like fraud proofs, validity proofs, these are cryptographic proofs. Like you can't break cryptography, and they formally like connect the Ethereum layer one to all of its layer twos. And so this is the trade-off that Cosmos, a pure Cosmos vision with complete sovereignty, does not do because Cosmos itself is so incredibly optimizing for sovereignty. But the Ethereum rollup landscape does make this trade-off. It does make the sacrifice that like, hey, we're going to commit to an external root of trust, an external reference point to ensure our security.
I
And so
guess
this is the trade-off space.
to see that trade-off, right? I guess maybe a contrast point is what's the difference between like being an app as a smart contract on top of Ethereum or on top of Solana?
Mm-hmm.
And like, what level of sovereignty do you have there
Mm-hmm.
versus being your own chain?
Right.
And I'm just like thinking through this in my head, but it seems very much like being your own chain. You have much more
So much more
like sovereignty there. You don't
sovereignty.
have complete sovereignty, which is like almost as it should be. Like users want the ability to exit. Like, and the
Mm-hmm.
entire point of layer twos is that there's some level of user protection and like decentralization that is preserved. But like, is that more? I think it's more than a smart contract app built on top of
Certainly.
a layer one, right? Because like as we've seen with certain smart contract apps, the DAO being a notable
Mm-hmm.
example, like rollbacks or what do they call it? Was the term used for that?
Irregular state
A
transition.
regular state transaction, like transition, can actually
Mm-hmm.
happen, and like that's a breach of sovereignty. Anyway, I guess that's a contrast point. So you'd
Mm-hmm.
say you have more sovereignty as your own chain than in an
Right.
individual smart contract deployed on top of a layer one.
Yeah. And like, I think one day there will be a uni chain, and that will be an application that is looking to seek more sovereignty for itself and become a chain. We're not there yet. Like, there's a bunch of hurdles that we need to get through in the Ethereum ecosystem to get there. But you can see how like the desire for sovereignty will produce chains, not applications. And like, again, the cryptographic proofs kind of tie, like Arbitrum and Optimism are not tied together except through the Ethereum layer one. And so they are interoperable with the central settlement hub. Like, my kind of claim is that, well, the Cosmos vision has kind of like floundered. It's like a big idea that hasn't really scaled. And so I think if you make the small compromise to sovereignty just by saying, hey, we'll allow the Ethereum to check our fraud proofs, you actually produce more total sovereignty, because that is the trade-off that produces the Cambrian explosion of
Yeah,
sovereignty
it
for chains.
seems very clear to me that like between Ethereum and Celestia and all of the layer twos, they have totally co-opted the idea of Cosmos. It's just like so you have complete sovereignty of chains. You just have like this root of like trust, right? Which is really interesting. You say in your article that there are a few things you get from this unbreakable vow as a layer two. So we talked about chain security already. There's two others though. One is composability. It feels like that hasn't really kicked in yet, David. Composability. So
It
all the
feels
layer two
like that.
chains. Well, it's true. It's like all the layer two
I
chains.
actually don't think it's true.
Okay, so
I want to
tell
take
me
it out from a
why,
different.
because we've done entire episodes
Mhm.
on how Ethereum has a massive fragmentation problem in its layer twos, and
Right.
the steps that like solutions that are coming online to sort of like fix this fragmentation problem.
Sure.
So, and like maybe it's not as fragmented as Cosmos, but then Cosmos has IBC as well, right? So like yeah, what gives you the sense that right now being in a layer two increases your composability?
So yeah, Ethereum gets critiqued for being fragmented, but ironically, Ethereum is the only network that's out there that's actually stitching together chains through cryptographic proofs. So, like, by contrast, the many layer one space is complete and total fragmentation, whereas the Ethereum layer two space is fragmented actually only by latency. And so the Ethereum is actually the only system actually binding together chains through cryptography. So it's actually the only system that's composable. The difference, like why Ethereum gets critiqued for being fragmented, is because like this is the Solana narrative, which is like, don't use many layer ones, just use our layer one. There's no fragmentation here because we are the monolithic layer one. We have as much capacity as possible, and we have as much sophistication as possible. We have like the Solana virtual machine, and we have like zero fee transactions with as much capacity as possible. So why would you need any other chain? So it's only fragmented from the perspective of like a single layer one that you are having that perspective from. But if you look at the totality of all layer ones, Ethereum is the most composed network.
I want to go back to the comment earlier, because you say another thing, the third thing that you say layer twos get from this unbreakable vow as a layer two is a unit of account, ETH being sort of like money. So you can, if you have a trustless bridge in your layer two that's backed by ZK proofs or validity proofs, you essentially have like crypto native ETH, like trustless ETH. And by the way, we should caveat this. This is the state on layer two beat of like how decentralized the layer twos are. Before anyone says, but layer twos are just a side chain. Like, first of all, that's too simple a narrative.
Right.
But it's also too simple a narrative to say layer twos are maximally decentralized and they're exactly like Ethereum block space. Like, both of those are wrong. this is the current state of layer 2. I would say decentralization, right? And Arbitrum is closest to being like most closely, almost fully decentralized, and kind of like a stage 1 needs to get to stage 2. The OP ecosystem is still in stage 0. So anyway, you can go to layer 2 beat if you want to see sort of like what the centralization vectors still are for some of these chains. But anyway, back to my point. So ETH is money. Like that's a benefit to the layer 2s. When I put out this tweet and I said, hey, yesterday Base made almost 700K and only paid Ethereum 2,500 for that, people responded and said, that's a mega bearish ETH. Like it's cannibalizing itself. It's losing all its revenue.
Right.
Like that's terrible. Now layer 2s are kind of like becoming the tail that wags the dog. Like they get all of the revenue. And what about poor ETH like block validators, right? Where their revenue source is kind of like dropping to 0. So what's your take on like? I mean, maybe this was the kind of the right move for decentralization, David, to be in this upper right small block, like VM type of quadrant. But maybe that was the wrong decision from an ETH value accrual perspective. What's your take on this?
So what were those numbers for the base chain? They made $673,000, and then they paid $2,500 in a 1 day window
on one particular day when markets are heating up. So like again, this is just like not a trend line you can extrapolate and just be like, oh yeah, this profit margin is going to exist forever. Like, but all those things aside, yes.
Yeah. Okay. So what happens when the cost of producing a chain is $2,500 a day, and that same chain is generating $700,000, $600,000 of revenue? What do you think happens?
I think we're getting a lot more chains.
You get a
whole lot more layer 2s.
You get a ton more. And so this isn't some sort of like, hey, we're going to have layer 2s because of sovereignty. No, we're going to have layer 2s because it's profitable as hell.
A good business model.
It's a good business model. And when we have many, many, many layer 2s that are all independent sovereign chains, except for the cryptographic proofs that provide strong settlement assurances between the layer 2 and the layer 1, those are all ETH monetary networks. This is like if Visa is a monetary network spreading around like dollars or whatever unit account you want to run through Visa, all layer 2s are monetary networks around ETH. And so like, yeah, so the Ethereum design philosophy is like take off the brakes for layer 2s, let 1,000 layer 2s bloom. They all use ETH as money. They all like suck up ETH. Like look at how many all the ETH that's being sucked up.
But they don't have to use ETH as money. Back to your comment on sovereignty and like even do you remember Starknet announced it? They're using their own Stark token for gas. They're not necessarily using ETH as money.
Yeah. But yes, this is a choice.
They still have to pay their taxes to Ethereum in like block space. Basically, the fee is denominated in Ethereum, but they're not fully ETH as money. They have sovereignty over that. But even still, I think what you're saying is like the trade-off is worth it, right? Because you make it up in volume, make it up in chain volume. This is exactly what Solana says,
right? Totally
about their fee market. The reason why like fees on Solana are sort of sustainable, according to someone who is a Solana bull, is in the fullness of time you'll have like hundreds of thousands of transactions per second on your layer 1. You'll have so many transactions that will be super cheap. It will culminate in like some pretty decent revenue. Like in addition to MEV and the ordering of blocks and the revenue unit for there. It's kind of the same thing. It's kind of the same argument.
Yeah, except one produces many, many, many layer 2s. One actually produces more net new blockchains into the crypto space, and one does not, which is why I kind of just philosophically align with the Ethereum design strategy, because it's both. It is the big tent chain. It is small blockers on the bottom, big blockers on top.
So you just identify with the philosophy is what you would say. But are you also making the argument that this is kind of like the winning philosophy?
Yeah, like so this is why I call this the grand unified theory of Ethereum architecture. It is, you have a philosophy, yours fits inside of the Ethereum design architecture. You have a belief system, it can fit on Ethereum and be composable with the rest of the Ethereum ecosystem. What do you believe? We have room for you.
Yeah, I guess my take on this is you may be right. And it's certainly something that, like from a thesis perspective, I also probably subscribe to, I guess the best take. But I think that the fight, that battle, and the convergence that we're seeing, we're already seeing Bitcoin become a bit more like Ethereum, right? And like in some level, I think Solana will also become a bit more like I think there will be a Solana L2 community, let's say. Like that's what I think. I don't know if that's true or not, but I think it's kind of like this end game type of convergence that's going to happen. And so to prove out your like thesis, it's going to take like years. It's going to take decades. And in the meanwhile, I think these 4 quadrants that you set up, where you have like non-VM small blockchains, and then VM small blockchains, and then you have like non-VM large blocks, and then VM large blocks, they're still going to occupy important niches in crypto and fight each other. Like they're gonna fight for the next like couple of decades, right? And we might end up, David, in a world that is a multipolar world where there's not like a power law winner of these types of things. It's just like similar to kind of like I guess the multipolar world that the world is moving to, where U.S. dominance is kind of like like falling, where you have like this nexus of architecture approaches and like zones of influence and that kind of thing. So it could play out that way as well.
I think that's right. I don't think Ethereum invented this endgame. Ethereum discovered it. And the reason why we're seeing convergence towards this, what I think is the conclusion of blockchain design, which is a small block anchor for a big block universe, or trivially easy to verify layer 1s with a sovereignty landscape of layer 2s. The reason why we're seeing convergence there is because everyone is trying to like feel out this like, blindfolded, feel out the walls of this universe, this crypto design architecture universe. And they're all kind of independently coming to the same conclusions via their own routes. But like the pull, the gravitational pull of this design conclusion pulls on all of these systems nonetheless.
One thing that I would add for the Bitcoin and Ethereum camp that I would say that just sort of maybe, at least in my own mind, kind of like supports the thesis is I think it is much harder to do kind of like max decentralized, kind of low layer, settlement layer, high economic bandwidth, low, like small block layer. I think it's much harder to do that and keep that decentralized the entire way than it is to do something on the large block side of things.
Right.
And
You
for
see
me,
a fierce competition in the large block layer 1 monolithic.
this is
chain
how
space.
I've always seen it. For me, that occupies like a moat. Like go try to be more decentralized. Launch your VC chain and go try to be more decentralized than Bitcoin today or Ethereum even today. Like go try that.
Imagine like being a layer 1 designer and be like, hey, we're going to start with like really slow, expensive transactions.
We're going to max decentralization, right?
Yeah.
Like you can't do
We're
that.
going to
It's
do
just
10 transactions
impossible.
per second and they're going to each cost $1.
Right.
And why would any VC fund that? Because you can't bootstrap that way.
Right. So I
That
see
window's closed.
the moat there. So long as people actually value and like the world values like decentralization, there's just like a massive castle wall like level moat there. Whereas in some of these other quadrants, like even take Celestia or Solana, okay, your value proposition is high TPS, right?
Fast,
And
cheap.
so what I've seen with Solana is like, again, this is own personal take. So like, Solana maxis will hate this right now, but Solana is going to have to defend itself against new higher TPS entrants that are VC funded. And so like the way it defends itself is network effect, its ecosystem, developers, community, all of these things, right? But like it's going to have a lot of competitors, and even now does like Move, Sui, Monad, which is like coming online, doing like high TPS, like it. So that space is, I think, on this board here, going to be harder to hold. At least that's a hot take. From
that makes sense to me because like block complexity, like block sophistication and block size, there's actually no like maximum upper bounds there. You could always make a more monolithic layer 1. You can always like engineer more capacity into your layer 1. And so like there's always going to be competition there. It's always going to be true. And before Solana, actually, there was EOS, right?
To Solana's credit, I've been very impressed with the staying power and the mind share that it's had. It does seem to have something that is a cut above other high TPS like big blockchains that have started in the past. All right, David. Well, this has been great. Is there anything else you'd say to kind of like wrap this whole thing up?
Yeah, I think I've said this point, but I kind of want to reiterate it one more time. The Cosmos conclusion actually wins at the end of the day, no matter what. Like Cosmos actually just started at the end game, and now Celestia and Ethereum and Bitcoin are now all kind of competing to get this Cosmos universe to be built on top of their blockchains. And so you kind of got to give some credit to the Cosmos people, because they just figured this all out. They just kind of like skipped to the end a little too soon, and they didn't build the anchor to like compose everything. But like the Cosmos endgame is ultimately what all three of these like ecosystems that want layer twos to be built on top of it, that's what they want. They want the Cosmos universe. And so like Cosmos is just waiting at the end game. It's like, oh, you guys have finally arrived. But the thing is, like, they weren't able to compose themselves before either Bitcoin or Celestia or Ethereum showed up. I just think it's super interesting, like how this is playing out.
Some of those, you get the architecture right, but you don't have enough of kind of like it's too much anarchy. You don't have enough coordination to kind of glue it all together and like actually make it happen, which is interesting as well. All right, guys, this has been Bankless Takes. Hope you appreciated it. Got to end with this. Crypto is risky. You could lose what you put in, but we are headed west. This is the frontier, not for everybody, but we're glad you're with us on the Bankless journey. Thanks a lot.